Hey, I'd like to talk to you first about solving inequalities in two dimensions. And I know that that's a really scary term, but it really just means solving things that have like less than or greater than signs. And to do it in two dimensions would be to put it on a graph of like an XY axis. And we're going to solve inequalities both graphically and algebraically today. Now, if you're following along, we're using the integrated 3A CPM book. I'm going to be on page 152, and I'm going to do number 3-122. So let's go ahead and let's get started. So I have two inequalities. One happens to be a quadratic function. It's going to graph a parabola. The other is a linear function. It's going to graph a line. Both are going to involve shading because I have inequalities. I love graphing parabolas, and I put a lot of detail into my parabola graphing, so you'll notice that the first way that it's given to us is it's given to us in standard form, and I've gone ahead and factored it, and the reason why I did that was to set y equal to 0 and define the two roots. And so my two roots here happen to be x equals 3 and x equals -1. Then I'm going to go ahead and complete the square in this parabola, moving the 3 over to the other side, looking at that -2, dividing it in half, and then squaring it. So when I do that, I get a 1, and if I put a 1 on one side, I got to put a 1 on the other side. So that trinomial is going to turn into x minus 1 quantity squared, and then I get a y plus 4, and I'm going to bring the 4 to the other side, and there you have vertex form. So my vertex is going to be at 1, -4. So now I have two roots and a vertex. At this point, I could graph it, but the last thing I like to do is I like to x equal to 0, and then I get the y-intercept at -3. All right, I feel like I'm pretty ready to graph. Those are my roots. There's my y-intercept. There's my vertex. And I'm going to throw down a dotted line. The reason why the line is dotted is because y is not equal to that graph. My y values are going to just be less than that graph. So if you think of, well, where would the y values less than that graph be? And they would probably be below the graph. So I'm pretty sure my shading is going to occur below the graph, but to verify, I'm going to go ahead and use a test point. Always pick a point not on your graph that you just graphed. So 0, 0 is not on my graph, and I'm going to plug in 0, 0. Really, you could plug it into any form of this parabola that you want, any form of the quadratic. I'm just going to go ahead and plug it into the original standard form. And notice I get a false. And so because I get a false, I'm not shading there. I'm not shading at 0, 0. So I'm not shading essentially up on the parabola. I'm going to shade below. I'm going to pick another test point that happens to verify this so that I get it true. I'm going to pick a point that's not on the parabola. That's a nice, easy point. You can use any point, really. I'm going to pick the point 4, 0. You can notice 4, 0 is not on the parabola. So when I use 4, 0, I get a true. And so where 4, 0 is, I'm going to go ahead and shade, but really I'm shading every point. Every point below that parabola would also make this true. So there's my shading. Okay, next I'm going to do the linear function. I'm going to end up graphing the line. Now I know you've graphed a line hundreds of times. So this line has to be shaded with all of the y values that are less than or equal to this line. And so I like graphing my linear functions kind of the same way that I graph my quadratic functions, really any function. I let x equal 0 and I let y equal 0. I like to find the intercept. So if I let x equal 0, my y-intercept is at 2. And if I let y equal 0, multiplying both sides by 4/3, my x-intercept's at -8/3, which is somewhere between -2 and -3. So I know where this line is going to cross the x and the y axis. Okay, finally my slope is at 3/4. I'm going to go up 3 and over 4. And by putting all of that in, I get a line. And my line is solid because remember, y can equal that graph and y is everything below that graph. So I'm pretty sure I'm going to be graphing and shading below this line, this linear function. But just to be 100% sure, again, I'm going to use a test point. And I'm going to use the test point 0, 0 because 0, 0 is easy. And notice when I plug in 0, 0, it's true. So that means I will be shading there. there being below that linear function. So I'm going to be shading everywhere below that linear function. Now, it's kind of hard to see, but can you see where the purple intersects the yellow? Every single point where the purple intersects the yellow, that's what we call the solution or the solution set to this problem where these two graphs intersect. So I'm going to, there you go. So take a look at that. That's going to be my solution set. Now, since we're really good math students, we're also going to go ahead and find out where those two values are. Sometimes people call those the critical values. Those values where the two graphs actually intersect. And I'm going to go ahead and set those two equal to each other just so that I can find those two ordered pairs. Okay, I don't really like fractions when I'm solving, so I'm going to go ahead and multiply both sides by 4. Make it a little easier. I'm going to bring the 3x to one side and also the 8 to one side, setting this equal to 0. Okay. At this point, you can either you can solve in various different ways. You can either factor, or you can use the quadratic formula. I'm going to go ahead and factor it just because I love factoring. This factors nicely. And since they're both set equal to 0, I'm going to go ahead and solve. And so I have x equals -5/4 and x equals 4. So those 2 points right now, I know their x values. I'm going to just need to find their y values. How do you find their y values? Take those values and plug them in. You can plug them into either function, but I like plugging them into the easiest function. In my case, the easiest function would be the linear function. I'm going to go ahead and plug in 4 and end up with a y value of 5. So those two graphs touch at 4, 5, and they also touch at 17/16. So now I have those 2 points. Okay. Put this into Desmos, great graphing utility if you haven't tried it already. And Desmos shows me those 2 intersection points. And yes, Desmos does do inequalities also. And you can hover on Desmos, the y equals section. There's like a little button to the left with a color. And you can make your graphs dotted or solid if you want to. And right there, that's the intersection. Thanks. I hope you have a great day.